Hey guys, I hope you're doing well. I know it's seems like forever since we've seen each other, but I hope school is going well. I hope e-learning is going well. I did want to touch base as this is the last week. So it's the last week of our class, it's the last week of e-learning, it's the last week of grades. So I just wanted to touch base one last time to remind you to please, please, please be really careful not to get behind. Um, Friday the 22nd is the last day for assignments. If you need me, I am here. If you need help, I am here. All you have to do is shoot me an email, um, post a private comment, anything like that. And I am more than happy to help you any way that I can. Okay. Recording all this, not doing it face to face is not my ideal scenario. As you all know that I'm much more of a people person and a hands-on activity kind of person, so I apologize, but we are working with what we have, and I am trying really hard not to overwhelm you. So I hope that I'm succeeding in that. Just to kind of give you an idea, today is going to be the last day of any new concepts, okay? So tomorrow we will practice and review. Thursday, we will review for our test. Our last major grade, our last test will be on Friday. Now, this is going to cover a lot of stuff, okay? This is something that I would normally have broken into 2 units, but because we are really just kind of glossing over everything, and for the sake of the fact that we have had like 4 weeks of learning, we put it all into one. So it's going to be everything from signs of a chemical reaction, balancing a chemical equation, types of reactions, moles to particles, moles to grams, grams to particles, and percent composition, empirical formula, molecular formula, what we did yesterday with mole ratio, and then what we do today. Okay, so please, please, please just hang tight. We are almost done. But we will do a help session just to drop in. If you have a few questions, you can drop in and ask through Zoom, but keep an eye out for that. It'll be either Wednesday or Thursday. Okay, so yeah, let me share my screen with you, and let's look at what we're working with. Okay. All right, guys. So here we go with stoichiometry. So yesterday we did moles to moles. Okay. So that was considered our mole ratio. Super duper basic introduction to this concept. Okay. And hopefully you thought, oh, wow, that was really easy, Miss Shoemake. So we're going to go with that. If you didn't think that, if you were like, oh my gosh, I can't believe she's going on, please, please, please shoot me an email. This does not have to be super duper hard, okay? So sometimes just a simple question and a sentence or 2 I can give you back can really, really, really help, okay? So don't feel like you're barely staying afloat with this. Just ask, okay? Please, please, please just ask. Okay, so let's look at this first equation here. Let's just look at the mole to mole side of this, okay? So if I had this first chemical equation, let's note the type of reaction of this, okay? So what type of reaction do you think this is? So remember, our types of reaction are synthesis, decomposition, single replacement, double replacement, acid-base or neutralization, and combustion. So what type of reaction is this? Now, if you're a little confused with this, I asked you some questions about that yesterday. One of the big things we want to note is that it has water in the end, okay? And it also has oxygen in the beginning. So what always has to have oxygen? What type of reaction is this? All right, so when we do moles to moles, okay, we always want to look at the coefficients in the beginning of the compounds. Now notice this first one does not have a coefficient, so remember that's going to be a 1, okay? And these coefficients are pretty much your moles. So like, let's say if I were to have 5 moles of oxygen of O2 in the beginning, and the end, I'm gonna get 5 moles of water. I mean, excuse me, 4 moles of water. I don't know where I got 5 from. Okay, so if I have 5 of oxygen in the beginning, I'm gonna have 4 of water in the end. Okay, so again, just don't overthink it. It's super duper easy to overthink this, but it's a very, very basic concept. Now today we're digging a little deeper. We're going a little further. Yay! And we're combining. So remember the other week, it's been like 2 or 3 weeks by now. We learned that 1 mole equals my molar mass, right? Now guys, remember your molar mass is just the mass of the entire thing. Okay, so like how many of that atom you have times the mass and then add it all up. Okay, also just a little reminder note, molar mass is going to be your grams. So when we did mole conversions, this was one of the 2 conversions we used. It was this and Avogadro's number. Okay, this is what we're working with today. Okay, this is what we're working with today. So let's look at our first problem. Okay, we have this combustion reaction. Did you get it right? Here, and we know it's combustion because it's fuel plus oxygen gives you carbon dioxide and water. So guys, remember, anytime you see water in the end, I automatically want to first look at combustion and neutralization. It cannot be a combustion or neutralization if it does not have water, okay? So in order to be one of those 2, it has to have water as a product. Now, can it be some of the others? Yeah, totally. But a really good go-to is go ahead and look at those 2 if you have water as a product. And then at least you can eliminate those if it doesn't fit the other category, the other classifications. For this problem, we're starting with 20.2 grams of C3H8, and it says it's burned in the air. So guys, if it's burned in the air, is my oxygen being limited? Am I only allowing it to get so much oxygen? No. So if it's burned in the air, that means that's just letting you know you have excess oxygen, so it's not going to affect it. We are not getting into limiting reagent and excess just for time's sake, but that's a really, really easy conceptual connection once you get this. The question is asking how many grams of CO2 are formed. So guys, different from yesterday. Okay, so let's make our little notes. We start with grams and it's asking us to end with grams. Remember, yesterday was moles to moles. The scary thing about this, which really isn't that bad, is that you're going from one compound to another. But remember guys, yesterday we figured out how to go from one compound to another, and remember, it wasn't that bad. So let's look at what we're starting with. We're starting with 20.2 grams of C3H8. Now for these guys, I am gonna hold on to my compound name, kind of like yesterday, because once we're flipping between compounds, it's really easy to make careless mistakes. All right, now before we go any further, how many sig figs does my answer need to be? Okay, sandwich zeros are always significant, so my answer needs to have 3 sig figs. Are you with me? Okay, let me erase some of this just to give me some more space. Now, when I go through this, let's go ahead and make my T-chart. Okay, I am starting with grams of C3H8, right? I need to get to grams of CO2. In order to flip compounds, to switch from one to another, I have to be in moles. Right, like yesterday, you have to be in moles. Well, guess what, guys? We can get to moles because we know up here that 1 mole equals my molar mass. So let's say, okay, so 1 mole of C3H8 is going to equal my grams of C3H8. Now let's take a second though, guys, and let's figure that out. I'm totally going to run out of space. So let's do this down here. So I have C3H8. That means I have 3 carbons, okay, at 12.011. That's going to give me 36.033. I have 8 hydrogens at 1.008, which is going to give me 8.064. And when I add all of these up for my molar mass, it's going to be 44.097 grams per mole. Right? And we know how to do this. This is my molar mass. We know this. So guys, this number is going to go right up here. So 44.097. Now, this does take me from grams to moles. So remember now my grams of C3H8 have canceled out, leaving me with moles of C3H8. Now guys, is it asking me for moles of C3H8? No, I need to get to CO2. So let's look at how we're gonna do that. We know if moles of C3H8 are on the top, moles of C3H8 need to go on the bottom. Well, what do I know? I know for every one C3H8, I have 3 moles of CO2. Do you see it? Okay. Now, I am to the correct compound, right? Because it's asking for CO2. I'm at CO2 now. Now, the problem, guys, though, if I cancel all my units out, moles of C3H8, moles of C3H8, I am to moles of CO2. But that is not what the problem is asking me for. The problem is asking me for grams. So I know, again, up here to this conversion, I know for every 1 mole of CO2, my molar mass of CO2. Now, the question is, again, what's your molar mass? So CO2, so carbon is 12.011. Oxygen, so 2 times 15.999 gives me 31.998, which is going to give me a molar mass of, sorry, I'm running out of room, a molar mass of 44.009. Is that what you got? So that's what I'm going to put right here, that spot I don't have room for. So 44.099. 009, excuse me. So 44.009, and that's going to be grams of CO2. Now, let's double check my unit of measure. Okay, so grams of CH3 canceled out, moles of CH3 canceled out. Ooh, now I can cancel out my moles of CO2, and that leaves me with grams of CO2. Well, is that what the problem is asking you for? Yes, totally. All right, so let's erase some of this excess stuff. All right, so really, really important as you go through this, guys, make sure that you are multiplying across the top, multiplying across the bottom, and then divide. Here it's not necessary, this one's not necessarily going to be affected too much by that, but a lot of times you'll have more than one value on the bottom. Okay, so just be careful. All right, so let's take a second. Let's multiply across the top, and let's see what you get. Okay, so across the top, I got 2,666.9454, and my bottom value is 44.097. So what type of answer are we going to get? All right, so when you solve this, now, real quick, guys, you should hopefully have a calculated answer by now, right? Okay, so my calculated answer, I'm having to jump all around, I apologize. My calculated answer is 60.47966 and change, okay? But I only want 3 sig figs. So if I wanted to get this number down to 3 sig figs, what would your answer be? It would be 60.5, right? So 1, 2, 3. We want to drop everything after the 4. But guys, remember that 7 is 5 or greater, so it's going to bump the 4 up. Now, I'm not done. I need a unit of measure. What is your unit of measure for this? Okay, your unit of measure is grams. Now, not just grams though, grams of what? CO2. Okay, does that kind of make sense? All right, let's try another one. All right, so let's look at this next problem. Give me a little more space to work with. Okay, so next one. So similar problem, similar path to our solution. So when you look at this equation, all right, it says the problem, it says a chemical reaction requires at least 215 grams of HCl, so hydrochloric acid, okay? How much PCl5 will be reacted with water to make this much HCl? So if you're in a lab and you know you need at least 250 grams of HCl, how much PCl5 must you have started with? That's what you're looking at. Okay, so again, you write what you're starting with. So 215 grams of HCl. Okay, oh gosh. Okay, remember you want to think about your sig figs. So 215 is going to be 3 sig figs. Okay, and when we do our little T-chart, okay, we know we do not want HCl in the end. Okay, right? We've said we wanted PCl5. So in order to get to PCl5, we must get to moles. All right, so let's look at our HCl. So we need, if grams are on the top, we need grams of HCl on the bottom. And we know that that will equal 1 mole of HCl. Now, this is going to be my molar mass. Okay, and remember your molar mass is just the masses added up. So this is a really easy one. So it's hydrogen, which is 1.008, plus chlorine, which is 35.453. And when you add this all up, you get 36.461 grams per mole. Okay, so we're gonna have 36.461 grams and 1 mole. Does that make sense? So, okay, so when you look at your units, okay, these units of grams of oh gosh, wrong way. These units of grams of HCl have then canceled out, leaving you with moles of HCl. Now guys, remember you don't want moles of HCl. You want grams. How much? Much is a quantity, which I guess could be moles. I would have to be a little more specific probably. Of PCl5. So if we have moles of HCl on the top, moles of HCl is going to go on the bottom. Why are moles of HCl going to go on the bottom? How many moles of HCl do you have? You have 5. Where do you get the number 5? Right here. Okay. And what compound are we going to be going to? We're going to be going to PCl5. So how many moles of PCl5 do you have? 1. Now, guys, in the end, is it asking you for moles of PCl5? No, it wants to know in a lab, how much PCl5 do you need to start with? You're not going to measure your chemical by moles, not in a lab setting, not when you're doing an experiment. You're going to measure it by grams, okay? So now we need to get off of this moles of PCl5 and we need to get to grams. So we're going to put moles of PCl5 on the bottom so that it cancels out, and grams of PCl5 on the top. Now remember, in order to do this, we need our molar mass because we know 1 mole of PCl5 equals that molar mass, okay? So molar mass for this little guy, so phosphorus is 30.974. Chlorine is going to be, there's 5 of them, so 5 times 35.453 gives me 177.265, which gives me a total of 208. Oh gosh. 208.239, and that's going to be grams per mole. I can't. Okay, so that's going to be what goes up here in my top. So 208.239. All right, now guys, notice when you go to solve this, okay, we want to double check that our units cancel out, leaving us with what we're looking for, which they do. Moles, leaves us with grams. Okay, you're going to multiply across the top, and you have to multiply across the bottom, especially this time, because notice you can't just pull that one number, okay? And then you're gonna divide. So take a second, guys. Let's plug this into the calculator and let's see what kind of answer we get. Now, I'm gonna ask you to give me your answer on this puzzle. I want 3 sig figs, okay? I want 3 sig figs. So what is your answer? Okay, when I did this problem, okay, I've got my answers were, let's see, 44,771.385 over 182.305, which gave me a calculated answer of 245.585063. Now, guys, remember, and I just told you before you put your answer in that I want 3 sig figs. So 1, 2, 3, which means my number would stop here. Now, notice, guys, this last number I want to drop is a 5. So what happens to the number right before it? It bumps up. So my answer is going to be 246. Okay, now, what is your unit of measure? Along with your compound, you have to give me your compound with this, okay? So I'm not just looking for the unit itself, I'm looking for the unit and compound. So tell me right now, what's your unit and compound? Okay, it's going to be grams of PCl5. All right, did you get it? All right. Obviously, if I ask you if you got it or not, I'm not going to count it off. If you got it wrong, it just helps me to understand kind of where we're at, even though I can't be there to figure really that out. Okay, so